Alright guys, today we're going to go Math 2, Unit 6, Lesson 4, Similarity in Right Triangles. This is basically going to be some homework help to go along with your lessons for this week. So, beginning with the first few ones, the first questions are asking you to identify some portion of this triangle to the right. The hypotenuse, if you recall, is the line that, the segment that's directly across from the right angle. So our hypotenuse, if this is our right angle, is going to be over here at xy. So we can label our hypotenuse as xy. When it asks for the segments of the hypotenuse, what it's asking for is when you take the xy, well, what are the two parts you have? We have this first part here, xr, and we also have the second part here, ry. And ry are the two segments that we have, and I could draw them as segments with lines over them. Sorry about that. The altitude is what we call the line that goes from the original right angle and goes straight down to form another right angle on the hypotenuse. So this is my altitude line right there, which is segment ZR. And then what's asking for the segment of the hypotenuse adjacent to ZY. Well, this is ZY all through here. That's my ZY. And the segment that is adjacent to it would be, right beside it, RY. And that just means the next two. Adjacent's next to. All right. Now, when we take a look at the next ones here, you have a series of triangles. They want you to write a similarity statement relating the three triangles to each figure. I'm using a pencil today just so I can help you see this a little better. Sorry, I'm zooming in a little bit here. I'm going to look at number 5, for example, first of all. I have the large triangle to begin with. I have R and Q and T, and that's my initial triangle there. And so I could start off by saying that triangle RQT is going to be similar to another triangle. Now, with this first triangle, if I want to think about sides, this is my right angle here. Fill that line, it's a little light. I essentially have my short side, my long side, and my hypotenuse to start with of my original triangle. In order to keep things in the same order, I can see I started with R at the top. I said I went short side to the right angle and out. The important part here is that you write it in the same order. So let's take this inside triangle right here, this one right there. I'm going to use that triangle next. Within this triangle, I have my short side is here, and my long side is here, and my hypotenuse is here for this triangle in the middle. That's horribly blurry. I apologize. Let's see if I can get a little closer, nicer. Not really. Quality camera here. Sorry about that. So short, long, hypotenuse. So on my original, I went short to long to hypotenuse. So here I'm going to go ahead and do the same thing. And I can see I want to go to the right angle. So I'm going to go ahead and do Q here to my right angle, S, and then S to out to the side, T. And there's my second little triangle. And that's going to be similar to my last triangle, which if I erase my circle, is this triangle here. And in this triangle, my short side is that side, my long side is this side. There's my right angle, and here's my hypotenuse again. And so we're going to go from the short to the right angle. So we're going to go from R to S, and then down to long side Q. So it's a matter of just finding out what are the three triangles you have and then relating them to each other so that you're in good shape there. Okay, let's see. You'll do the same thing for number 6 and 7 and 8. All right, let's take a look down here for geometric means. The geometric means, that is the part where we're going to say that different sides are equal to each other. This comes in the corollary theorem to theorem 62, where you're looking at a triangle like what you had above, and when you split this, what we're saying is essentially that because the altitude is going to be the same on both of these ratios, you're going to line it up so that you have one side over the altitude is equal to the altitude of the other side type of thing. So in this case here, for number 9, my x simply becomes, or my missing value is going to be x for this geometric mean. When I cross multiply, I have x squared, check, times 4 times 9 is 36. To determine what the value of x is, I will take the square root of both sides, and the square root of 36 is 6. On number 10, I want to do the same type of thing. I can see I have 6 and 12 of the numbers they give me, so I have 6 over y equals y over the other number, which is going to be 12. And when I cross multiply, I end up with y squared, which is going to be equal to 6 times 12 is 72. Now to find out what the square root of 72 is, I'm going to take square root of both sides. If you're not sure how to do that, one way of thinking about it is that with 72, if I don't want to put them together initially, what I'm doing is I have 6 times 12 is what forms up 72. And maybe you're great with numbers, maybe you struggle a little bit. I could separate this out a little bit more and say, well, 6 is actually going to be 3 times a 2, right, if I break that apart. And 12 can be written as 4 times 3. You with me so far? So I have 3 times 2 is 6. I have 4 times 3 is 12. Okay. And I'm looking for things that are squared numbers, some basic squared numbers. So right away I know I have 4 as a number that is 2 squared. When I look at what else I have, I know I have 2 3's. So those two numbers, if I take a square root, that means 3 times 3 is really 9. So let's go ahead and rewrite this real quick. So really what I have is I have a 2 times a 4 times a 9 in this set of numbers here. So I'm taking the 3 and 3 making a 9. So when I take the square root of that whole thing, the square root of 4 is 2, the square root of 9 is 3, and the square root of 2 is just the square root of 2. So I'm left with 2 times 3 is 6, square root of 2 is what the value of y is. Okay, so I'm taking this number 72, and you might have a different way of looking at it. I'm just kind of showing you how you can break that apart to smaller numbers that are more manageable to figure out what the value of y is for number 10. Does that make sense a little bit, I hope? So we're trying to say, okay, it's 6 square root of 2. It is the square root of 72, so if you have another way of breaking that apart, you certainly can. 72 could also be written as, what do we have, 8 and 9? Yeah, and 8 is the same as 4 and a 2, and we still have the 9. So I have a square root of 4, square root of 9, just like I did here, and I'm left with just a 2 underneath the radical. So that's number 10. Number 11, just to show you one more real quick, how do you set up on your own? To set up number 11 on our own, we could take 14 over x and make that equal to x over 12. Again, I'm going to cross multiply and end up with x squared equals 12 times 14. 12 times 14. 12 is the same as 4 times 3. And 14 is 7 times 2. Let's break that apart there just a little bit. So now I know if I take the square root of all of this to find out what x is, well, 4 comes on the outside now as a 2. And I'm left with a square root of a 3, 7, and a 2 multiplied together, which is going to be 42. And that's my answer there for number 11. Because I can't make, there's no square root of 3 or 7 or 2. Those are all prime numbers, so I'm done there. So I just multiply them together to find out what stays underneath the radical there at 42. You'll do the same thing for the other ones that remain. If you take a look at 14, I'll show you that one real quick because that's one's also maybe a little weird looking because you have already square root or radical numbers here. The idea is the same. We have square root of 50 over x equals x over the square root of 2, over 2. Not erasing this. So when I do the cross multiplication, I have x squared equals square root of 50 times square root of 2. because these are both square root, what I'm really saying is it's the square root of 50 times 2. The square root of 50 times 2 is 100, if I'm not mistaken there. And the square root of all that is going to be equal to 10. So in this case here, x is going to be equal to 10 for number 14. All right, looking down at the next section here, using the figure at the right to complete its proportion. This is one we're just going to match up the letters the way they should go. So if I have here the long side, D, to the short side of C, I'm going to have also this one's long side, this is the altitude, it's going to match up over here with the short side over here of E. So we're going to match up there with E there. Do the same thing with the other ones, looking for which ones match which problems here. So in this case here, we have 16, we have B over E. So this is going to be the hypotenuse with the short side. And what we're looking at here is, well, which short side we want to see? Oh, the short side is B, which means we're looking at this big triangle. And the hypotenuse in this case is across from the right angle, is F. You'll do that same thing with the other ones just to see what's missing. The hardest thing is, again, visualizing where are these triangles, what are they talking about. Probably just kind of get used to, if you're not sure, determine which one's your short side, which one's your long side, and where is your hypotenuse at. And if you can label them, then you can start to see which one is which. Flipping over to the back side now, we're going to be solving now for x and y. To solve these equations here, or to make this work, we're going to use the same theorems that we've already learned in this lesson. And so looking at number 19, I have two values. I have an x, this is an x here by the way, and I have a y here. I have 5 and a 5, and this triangle has been split apart with an altitude there. And there's my altitude and my right angle. So for number 19, to set this one up, I can take a look at a couple options. I don't want to really mix the x and y's together, so I'm going to break it up into two problems, is how I want to look at this one here. I'm going to take my larger hypotenuse of the large triangle with the short side, I'm going to call this the short side, or the base, and I'm going to make my equation like this. I'm going to say I have 10 on this hypotenuse to the base x, and that's going to equal, when I look at the other triangle over here, I could say, well, let's look at the one with the x, this triangle right here. My hypotenuse in this triangle is actually x, that's across from the right angle, and the base of this triangle, for this small triangle, is 5. So again, I used the big triangle and said the hypotenuse was 10 with the base of x. And then when I took the small triangle, I said, well, in the small triangle, my hypotenuse, the small one, is x, and my base is 5. So now I can cross multiply and end up with x squared equals 50. To get x by itself, I take the square root of both sides. 50 is the same as 25 times 2. And the square root of 25 is 5, and I'm left with a 2 under the radical for the value of x. Now I'm not done yet, because I also have to find the value of y. So to find the value of y, I'll do the same type of thing. Okay, I have a right angle here, but now I have a couple different options here. Because it's a triangle with an altitude, I can say the base of this one over the altitude, and use my neighbors here, equals the altitude of this one over the base of that one. So we have 5y over y equals 5. Cross multiply, and we end up with y squared equals 25, and the square root of both of those, we end up with y equals 5. So for number 19, your solutions are x equals 5 radical 2, and y equals 5. For number 19. Again, it's about playing with those triangles to see, are you on the right track? Can you see how they line up together and what matches what? Let's look at number 20 real quick. Okay, number 20. Once again we have a large triangle here, and when I look at it, I look and see that I have, first of all, I have this little triangle, and I have a large triangle. This part here is an x, and I have a y. I'm going to go ahead and set up the ratio this way. I'm going to do my hypotenuse of the little triangle, 100, over the short side, 50. And I want to make that equal to the hypotenuse of my large triangle. Okay, so I'm basically setting hypotenuse over short. That's how I'm setting my equation up. Is equal to, the hypotenuse of the big one is 50 plus x over the short side, which is 100. Right? So I set my equation up to say hypotenuse over the short side, hypotenuse of the little triangle is 100 over short side 50 equals the hypotenuse of the big one, 50 plus x, combined length, over 100. When I cross multiply those, I end up with a crazy number. Not too bad, actually. But we end up with 100. Well, let's first of all, let's reduce real quick. I don't want a big number, so 100 over 50 is actually what? 2 over 1. So I can reduce that before I multiply. So let's make it a little nicer to work with there. So let's cross multiply now. 2 times 100 is, this is an arrow, is 200, and that's going to equal 1 times 50 plus x is simply 50 plus x. Subtract 50 from both sides, and we end up with 150 equals x. So the value for x right here is 150. Again, I'm not done yet because I still have the value of y that needs to be determined as well, which is the long side of the large triangle. So to set this one up, I'm going to take, I have y. I'm going to go ahead and say, let's make it equal and equal, make a little fraction here. I'm going to put y here and y there, like we did on the front page. So if y is going to be my height, my tall side, I want to see which triangle do I already know a tall side of, so that I could use it as my corresponding part over here. Well, in this case here, I know that we have 150. I'm going to use my tall side of this guy right there. 150 goes with y. I'm going to use my tall side to my hypotenuse of this triangle and match it up to, my tall side, long side to my hypotenuse and match it up to this one. So which one has my long side? If that's my long side, my hypotenuse is 150 plus 50, which is 200. So let me just do that again, because I'm talking out loud and thinking while I'm doing it. I'm going to make a ratio of the long to the hypotenuse for both of these proportions. So with one triangle, I have my long side, use this one here, long side over the hypotenuse. And then I'm going to use another one where I have, this is my long side, and my hypotenuse is this length here, 150 plus 50. So when we rewrite that, we have 150 over y equals y over 200. And again, I'm going to cross multiply those out, end up with y squared equals 200 times 150. So I have a pretty big number here to multiply out to figure out, well, what's going to happen. Knowing what I'm going to do at the end, I'm going to take the square root of all this. I'm not going to multiply that out. What I want to do is just go ahead and break it up into parts that I know. 200 is the same as 100 times 2. Okay, I like that number a little bit better. 150 is the same as 15 times 10. Now, I like the 100. I'm going to keep it there because I know when I do the square root of 100, I can just take that out and I'm left with 10. Over here, I have 15, which can break apart into a 5 and a 3, and a 10 becomes a 5 and a 2. Whenever I get double numbers like this, I know that I could combine them back together again, but when I do the square root, I'm just left with 1 on the outside of the radical. So I have the 5s that are going to match up together, and I also have these 2s that'll match up together, and I do still have a 3 stuck inside of there. So when I do the square root of all of this, I end up with y equals, the square root of 100 is 10, the square root of 2 5s is 5, the square root of 2 2s is 2, and I still have a 3 on the inside. 5 times 10 is 50, times 2 is 100. Square root of 3 is what the value of y is. Okay, so my value of x went somewhere. Did I lose it already? Oh, yeah, sorry. My value of x we said was 150, and my value of y is 100 times the square root of 3. So the problems are a little bit messy. You probably want to work them out on a different piece of paper. As you can tell, I've used up a quarter of the sheet just to do one problem there, and you still have some more that need to be solved here as well. Okay, let's look at a couple more before we wrap this one up here. Looking at number, we'll look at number 20, and we're going to just look at 21 for now. Same idea. How do we set it up? I have an x, I have a y, I have long sides, I have short sides. This is my 40 right here. When you set it up, again, an idea might be to then label your sides. So let's say, for example, I know that I have a 40. I'm going to solve for x first. I just pick x because just what I'm used to doing. I have a 40 right here over this length x. So in this triangle, what I have is I have my long side over my short side. So long over short is sort of the ratio that I'm setting up. And because I want to get an x on the top so I get my traditional x squared when I cross multiply, I want to make x my long side and look for the short side. Well, in this case here, if this is my long side of a triangle, and here's another right angle here, and that's the long side, my short side would be this length right there. They don't give me that length directly, but what they do tell me is that the combined length of 40 plus something else is 60. Well, 60 minus 40 is 20, so I know the short length of this triangle is 20. So now I can put that into my proportion, and I can cross multiply and solve. And if x squared equals 40 times 20, okay, good with that. 40 times 20 is 800. 800 I can break apart as 100 times 8. 8 becomes 4 times 2. So when I do the square root of 100 times 4 times 2, I'm left with 10 times 2 times the square root of 2. Because the square root of 100 is 10, square root of 4 is 2. So on the outside I have 20, and on the inside I'm left with a radical 2, square root 2 there. So that's my value of x for this problem, number 21. To find the value of y, I want to do the same type of thing. In this case, y is my hypotenuse. So I'm going to go ahead and solve this here for y. I could say it's the hypotenuse of this one. I could also say that it's the short side of the large one. So it depends on how you want to set this up. Because I'm going to go ahead and put the y on the bottom part, or the denominator, just out of habit, and put that y there, I'm going to make my y initially be the short side. I'm going to write S here for short. And the number that I do know in this case, again, is the length of the hypotenuse of the large triangle. So my hypotenuse on the top. So the hypotenuse of the large triangle is 60 over the short side. So in this triangle here, if this is my hypotenuse, which is y, well, the short side of this triangle is here at 20. So I set it up as 60 over y equals y over 20. Cross multiply, and we have y squared equals 60 times 20 is 1,200. And again, that breaks apart into two numbers. That breaks apart into 100 times 12. 12 breaks apart into 4 times 3. So when I do the square root of 100, I end up with 10. The square root of 4, I end up with 2. And the square root of 3 is just the square root of 3. Combine my outsides, and I put 20. Square root of 3 is the value of y. So my x value is 20 square root of 2, and my y value is 20 square root of 3. Very strange numbers, a lot of work there, a lot of ways to break it apart, so you have to be able to kind of process and go through the algebra stuff there to solve those ones. Okay. 22 is the same idea. I'm running out of space there, so I won't do that one for you. The other ones you'll have to do is, like down here, 25 and 26 are similar, just to set it up. The altitude of the hypotenuse of a right triangle divides the hypotenuse into segments 9 and 12. Find the length of the altitude to the hypotenuse. So you want to set that up as a little picture, perhaps. Draw as a picture first. What's it asking? Well, we're dealing with right triangles, so I'll draw one. So a nice right triangle. Not very nice. And then we're going to have an altitude here. Right? So we have a right triangle. We have an altitude divides it into segments of 9 and 12. So I'll make that one 9, it's a little shorter, and that one 12, and I want you to find the altitude of the hypotenuse. So if I was to set this up using the theorems that I know, the short side over the altitude, I can call it x, equals the long side, equals the altitude over the long side 12. So I set it up that way, and I would then go ahead and cross multiply to solve that. So we have x squared equals 9 times 12. I'm going to break apart my 12 into 9 times 4 times 3. And when I do the square root of all of that, the square root of 9 is 3, the square root of 4 is 2, the square root of 3 is just still the square root of 3. On the outside I have 3 times 2 is 6, times the square root of 3 for my answer for my altitude. And that's all there is to it. Okay, that's enough for today. Hope that helped a little bit, and check in later for more solutions.